You're gazing at a beautiful full moon on a clear night. It's been there your whole life, reliable, glowing, pulling the tides like clockwork. But what if tomorrow morning you look up and it's gone, vanished? No explosion, no warning, just poof. The moon, Earth's faithful companion for 4.5 billion years, disappears overnight. Sounds impossible, right? But in this what-if scenario, that's exactly what happens. No more moon. No more lunar phases, no more eclipses, no more werewolf myths. But the real shock? The devastating chain reaction it triggers on Earth. First, let's set the scientific stage. The moon formed from a massive collision early in our solar system's history. A Mars-sized object smashed into proto-Earth, flinging debris that coalesced into our satellite. Today, it's about 238,000 miles away, exerting gravitational pull that shapes our planet. The moon stabilizes Earth's axial tilt at 23.5 degrees. That's why we have predictable seasons. It drives ocean tides through gravitational bulges, and it slows Earth's rotation over eons. Without it, billions of years ago, days would be just hours long. But in our reality break, the moon suddenly ceases to exist. No debris ring, no gradual drift, just instant absence. How does physics respond? Provocative question. Could Earth even survive the immediate gravitational snap? The point of divergence and immediate effects. The moment the moon vanishes, gravity recalibrates instantly. Earth's oceans, used to lunar pull, experience a massive release. Tides don't just weaken, they plummet. Normally, the moon causes tidal bulges. One on the side facing it, one opposite. High tides rise meters. Low tides expose seabeds. Without the moon, tides shrink to about 1/3 strength, driven only by the weaker sun. Immediate effect, coastal chaos. Massive tsunamis? Not quite, but sudden water redistribution causes huge waves as bulges collapse. Imagine U.S. coastlines, Florida, California, New York. Flooding from receding bulges, then stranded marine life as tides flatten. Nights turn pitch black forever. No moonlight means true darkness. Cities rely on artificial lights, but rural areas. Stargazing explodes, the Milky Way visible like never before. But wildlife suffers. Nocturnal animals disoriented, predators lose advantage. Earth's rotation feels a subtle jolt. The moon tidally locks our spin. Its absence accelerates days slightly over time. But immediately, minor earthquakes from gravitational shift. Shocking fact. Coral reefs and estuaries collapse without tidal mixing. Oxygen levels drop in coastal waters, triggering mass die-offs. Gas fisheries devastated. Think billions in losses overnight. What about humans? Panic ensues. Stock markets crash on uncertainty. Romantics mourn lost moonlit walks. But wait, could this expose hidden ocean floors, revealing ancient shipwrecks or resources? Branching scenario 1. If the disappearance happens during a full moon, maximum bulge collapse causes worse flooding in populated areas like the Atlantic coast. Provocative question. Would you trade beautiful nights for calmer oceans? Or miss the moon's glow enough to fear the dark? Short-term consequences and human impact. Weeks and months in, ecosystems reel. Tidal zones dry up or flood permanently. Mangroves, salt marshes, gone. Migratory birds and sea turtles lose navigation cues. Here's examples: Everglades transformed into stagnant swamps. California beaches erode differently without wave patterns. Tourism tanks, no more tide pools for kids. Energy shifts, tidal power plants shut down. But solar wind boom in darker, clearer skies? Human society. Astronomy surges in popularity. Light pollution laws tighten for better stargazing. But crime rises in ultra-dark rural areas? Longer-term hint, Earth's wobble begins. The 23.5-degree tilt stabilized by the moon's mass starts precessing wildly. Shocking fact. Without stabilization, tilt could vary from 0 to 85 degrees over millennia, like Mars, which flips extremes. Branching scenario 2. In a no-moon world, could humans engineer artificial tides or mini-moons? Imagine living it. Your favorite beach vacation spot, now a flat, tideless lake. Relatable for Americans. No more surfing big waves in Hawaii or clam digging in New England. But the real disaster unfolds over centuries. Long-term consequences in branching scenarios. Centuries pass. Axial instability dominates. Seasons go haywire. One era. Near zero tilt. No seasons. Eternal equatorial heat, polar cold. Another. Extreme tilt. Poles point sunward for months, melting ice caps entirely, then freezing oceans. U.S. impact Midwest turns desert or tundra alternately. Coastal cities like Miami underwater permanently from unstable climates. Life evolves. New species adapt to erratic daylight. Humans migrate underground or to domes. Alternatives. What if we capture an asteroid as a replacement moon, or geoengineer tilt stability? Branching scenario 3. Best case. Tilt stays mild for millions of years. Earth thrives with darker nights and stable-ish climate. Worst. Rapid flip to ice age or greenhouse hell. Deep discussion. Physics of angular momentum. Earth's spin destabilizes without lunar torque. Shocking fact. Mars lost stable seasons partly due to no large moon, violent climate swings. Provocative question. In this branching reality, would humanity unite for space colonization faster? In this what if the moon disappeared? Earth faces immediate calm oceans and dark nights escalating to potential extinction-level climate chaos. Thought-provoking. The moon isn't just pretty. It's Earth's guardian, keeping our world habitable. Appreciate it tonight. Next, what if the moon crashed into us instead? Total annihilation or new supercontinent? Binge the playlist for more reality-breaking science. Subscribe, like, comment your biggest fear about this scenario.